next example is for rotational mechanical system. So we will use the same process as the ones we're using for translational mechanical system. So we have here an example wherein we have J1 and J2. So from there, we can already determine that this one is a rotational mechanical system. Another indication is the presence of torque instead of force and the angular displacement. So the process is the same. We already identified that this is a rotational mechanical system. Now we have to get the free body diagram for this. So same with the mass, the number of free body diagrams also depend on the number of moment of inertia of mass, which are the J1 and J2 boxes. But the way we draw it is different. So for J1, we have these forces or this torque, and then we have this angular displacement 1, and the opposing forces are the ones connected to it. So we have here K, TK. So take note of the direction of the torque. This one is clockwise, and the opposing forces are counterclockwise. And then we also have the TJ1. The torque due to the inertia. Okay, so that's it. And then for the J2, we have displacement 2, and then we don't have here any applied force, so we just keep it as is. So we have TJ2, then we also have what's connected to it is TK, and we also have TB. So for TB, take note, we will use case 1 since one side of it is attached to a reference. Okay. But for TK, we can indicate here already that this is theta 1 minus theta 2. And same with this one as well. So ayun pala, please remember that the order of this theta 1 minus theta 2, theta 2 minus theta 1 depends on the perspective of the mass. So in this example, we put theta 1 first because this is connected directly to J1. So for the second free body diagram, we will indicate theta 2 first. Okay, so now let's move on to the force equations. So the number of force equations, of course, depends on the number of your free body diagrams. So for the first one, we have TJ1 is equal to J1 d squared theta 1 over dt squared. And then we also have TK is equal to K theta 1 minus theta 2. So the torque is equal to TJ1, which is J1 d squared theta 1 over dt squared plus K theta 1 minus theta 2. Okay, now we have to get the Laplace transform. Of both sides. So this T will be T of S is equal to J1 S squared theta 1 of S plus K1 theta 1 of S minus K theta 2 of S. Okay, so we can then rewrite this as by factoring out theta 1 of s as j1s squared plus k minus k theta 2 of s. So this will be our first Laplace transform equation. For equation number 2, we have with t j2 is equal to j2 d squared theta 2 over dt squared. We also have tk is equal to k theta 2 minus theta 1. We also have tb is equal to b d theta 2 over dt. So 0, because we don't have any applied force there, or torque, tj2 plus tk plus tb is equal to j2 d squared theta 2 over dt squared plus k theta 2 minus theta 1 plus b d theta 2 over dt. This is ODE, so we have to get the Laplace transform of both sides. That will be equal to j2 s squared theta 2 of s plus k theta 2 of s minus k theta 1 of s plus bs theta 2 of s. So this will be our second equation. Then we can substitute I'm sorry, we have to first separate theta 1 and theta 2 of s in these terms. So that will be 0 is equal to theta 2 of s times j2 s squared plus k plus bs minus theta 1 of s k. So I want to move this term to the other side. That will be theta 1 is equal to theta 1 of s is equal to theta 2 of s. Oops. j2s squared plus k plus bs over, yung kasama ng theta 1 kanina is k. This is our equation number 2. Okay? So now I can substitute this to this. So t of s is equal to theta 2 of s times j2 s squared plus k plus bs over k. So this is still theta 1 of s, so this entire term, and then we will copy the rest. j1s squared plus k minus k theta 2 of s. T of s is equal to theta 2 of s j2 j2s squared plus k plus bs over k times j1s squared plus k minus k. So the transfer function is actually equal to ano yung output natin? Laplace transform of theta 2, which is theta 2 of s. This is the Laplace transform of the output over Laplace transform of torque. So it's in s domain, t of s. So we want to get the equation for this. So we will cross multiply. That will be theta 2 of s over t of s is equal to k k over j2 s squared plus k plus bs times j1 s squared plus k minus k squared. So this is transfer function of the system. So just take note, you will know that your answer is correct if the s that's associated with j is always in the second power, the s that's associated with b is in the first power, and then k is in zero order. So that's same with translational mechanical system.